Today we're going to have some fun with electricity. We're going to learn about circuits by using Play-Doh and plasticine to make our own working circuits and learn about the two different types of circuits. We're going to apply this knowledge to a device called a makey, which has a number of different circuits which we can connect up to a computer. Once connected, we can use it to make things such as game controllers out of Play-Doh and plasticine, or pencil and paper, and even to make a piano that will play through the computer and be able to play things such as your fruit or your lunch, and to test it to see if it's a good conductor of electricity. It does mean that the electricity will pass between you and the device, but do not be worried. The device is at such low power it just sends a very small signal through. So sit back, have fun and enjoy. Hi everyone, what we're doing here is showing a demonstration of parallel circuits. Parallel circuits complete their own circuit from a common power supply. The advantage of a parallel circuit is if I break one point in the circuit, the other devices on the circuit do not break. What we're using here is Play-Doh, which is a conductor due to its high salt content. We're also using plasticine, which is an insulator due to its high oil content. Electricity can flow through the Play-Doh but not through the plasticine. As you can see, if I remove one of these lights from the circuit, the other lights are unaffected. However, I'll show you something interesting too. If I try to put this light back in the reverse manner, it won't work. Because this particular light is what they call as an LED, or a light emitting diode. The D in it stands for diode, which means it only allows electricity to pass through it in one direction. This over here is another example of parallel circuits. As you can see, this is very much in parallel to each other. The Play-Doh is on the other, in parallel to the other side, Play-Doh on the other side of the circuit, and as I said before, I can remove one piece from the circuit without affecting the rest. It is also much harder to short out a parallel circuit compared to a series circuit. Next, we'll show you the series circuits. Demonstration here, I'm going to show you a series circuit. We've moved into a dark room to show you a much greater contrast between the light and the dark. This is an example of a series circuit. The electricity must pass through every point on the circuit to complete the circuit. If any point is broken, the whole circuit is broken for every device on it. So this is an example of a series circuit. Now to have a go at using the makey. The makey is a device that will connect up what we have learnt in regards to circuits and conductors and electricity to a device that will interact via a USB port to the computer. It allows us to play video games via a homemade game controller out of Play-Doh and plasticine, and an electric current that will go through us and through to the to complete the circuit on the device, which will send a signal through to the computer, which will tell the Pac-Man which way to run. Not only are we going to be using Play-Doh and plasticine in this experiment, but we're also going to actually make a game controller out of pencil and paper. Now, the graphite in the pencil is a good conductor of electricity. So if we draw a game controller that has connecting lines to an electrode which connects up to our makey device, as you see here, we can control the Pac-Man by pressing the pencil drawn buttons on the paper. This allows us to play games and control the computer via completing the circuit when we press the pencil drawn lines. This is just one of the activities that we're going to be doing today. Also, we're going to be making another device which will be able to play the piano via the makey and fruit. In this activity, we're going to be looking at the conductivity of different types of food. We set up the makey towards a keyboard program that's on the internet, and we hook up connections to each of the food sources that we're going to check. Of course, make sure you have your earth or grounded cable connected to yourself in order to complete the parallel circuit. When I touch a fruit, if it does conduct electricity, we should hopefully hear a sound. As you can see, the bananas are perfectly suited for this exercises as they conduct electricity quite well for the makey's purpose. However, we need to test other types of food to see whether or not they will work in this process. So you'll be testing your lunch. In this activity right now though, I'll see whether or not an apple will conduct electricity as well. As you can see, my apple is also a good conductor of electricity for the makey purposes. Now you need to put your lunch, sandwiches, fruit, whatever you have in your lunchbox, and test to see whether or not it will be suitable for the makey keyboard. We're going to be using Ohm's law to measure the amount of current and resistance passing through a piece of Play-Doh. Play-Doh is a conductor, however it's not a very good conductor. As a result, we're using a microamp meter which measures amps at 1/1,000,000th of an amp. As you can see, I have the Play-Doh connected up in series through the amp meter, and we are registering at the moment 2,500 microamps. So, as you can see, I've put the two electrodes quite close together on this Play-Doh. I'm going to start separating and moving them further out. And as you can see, the further away I move the electrodes on the Play-Doh, the greater the resistance the Play-Doh provides and the less amps or electricity pass through. Also, at the moment I have it on 2 volts. That's important because we need to understand what voltage is passing through the power pack in order to work out the resistance in ohms of the Play-Doh. I'm going to up it to 4 volts, and as you will see also on the micrometer that the number of amps that have passed through the system have now also doubled as I've gone from 2 to 4 volts. This shows a straight line mathematical relationship between volts, amps and resistance.